I am going to discuss maximum subarray sum using dividend conquer method in this video. Already in the previous video I would have discussed the same problem using brute force method with the time complexity of big O of n square, and let's check using dividend conquer method whether the time complexity can be reduced or not. Maximum subarray sum problem is nothing but finding the contiguous subarray which has the largest sum. So, here we are going to use the dividend conquer method. So, this can be solved like we can use a recursive approach that divides the array into two halves and combining the results to find the maximum subarray sum, since the approach which you are going to apply here is dividend conquer method. Before I discuss the pseudocode, let me discuss the example. Let's take one example. The example problem is it contains an array which has some elements 1, minus 6, 8, 6, minus 2 and 5. This is the example array from which we are going to identify the subarray, the contiguous subarray which has the largest sum. If you check this array, it has totally 6 elements. Now let's start finding out the maximum subarray sum. Since we are applying dividend conquer method, we are supposed to divide the subproblem until there is only one element in the subarray. So, to divide the array into two equal halves, you are supposed to find the midpoint. If you find the midpoint is to find the midpoint, the formula is low plus high by 2 or left plus right by 2. This is our left and this is our right. Left index is 0, right index is 5. So, the answer is 2.5, which means till 2 it is going to act as one subarray and all the remaining elements is going to act as another subarray. So, the left subarray has only 3 elements, that are 1, minus 6 and 8, and the right subarray again has 3 elements, 6, minus 2, 5. Again, if you check, there are 3 elements. We are supposed to keep on recursively dividing the arrays until there is only one element in an array. If you check, there are 3 elements in an array, we are supposed to divide it again. Again, identify the midpoint. If you identify the midpoint, this is going to be the midpoint, 1 is going to be the midpoint. So, till low, and from low till mid is going to act as one subproblem. From mid plus 1 till right is going to act as another subproblem. 1 and minus 6 will be in one array and 8 will be there in another array. Again, there are 3 elements in an array in this subproblem. So, divide it again. This is how it would get divided. So, in the left subarray for this subproblem, there would be 2 elements, 6 and minus 2. In another subarray, there would be only 5. Again, if you check, there are 2 elements. Until there is only one element, we are supposed to divide the array. Since there are 2, again divide it. Now, in the array, in the left subarray, there will be only one element, which is 1, and in the right subarray only one element again, that is minus 6. And if you check this subproblem, there is already only one element, so it would retain the same. Then again, there are 2 elements, divided into 2 equal subarray, 6, minus 2, again there is only one element in the array, retain the same. Until there is only one element in an array, we just divided it into 2 equal halves. Finally, there is only one element in an array, so we can't divide it anymore. Now, we are going to combine the results to find the maximum subarray sum. If you check this subproblem, for each and every subproblem, we are going to identify the maximum sum. So, if you check this, in this array there is only one element, right? Since there is only one element for this array, the maximum sum is going to be only 1. So, it would return 1. From this subproblem, the maximum sum value we could get from this array is only 1. And then again, if you check this subproblem, again there is only one element in an array. From this array, if you get the maximum sum value, that is going to be only minus 6. So, minus 6 would be returned to the previous level. And then again, if you check this array, again there is only one element. So, the maximum sum value no other go, the same value only, which is 8, would be returned to the previous level. Again, here again only one element, so 6 only would be returned here. Again there is only one element, minus 2 would be returned as a max sum. And then again there is only one element, which is 5. So, the same 5 is going to be the possible maximum value that would be returned to the previous level. Now, come to the next level, from this level to this level. if you check in this sub problem, there are two elements. So, the possibilities are, the ultimate goal here is finding out the maximum subarray sum. So, here we have used a divide and conquer method. So, the possibility of getting the maximum sum value is going to be, because it should be contiguous array, right. So, the maximum sum value we could get either from the left sub problem completely, otherwise from the right sub problem, or else across the midpoint also we might get, right. So, totally there are three possibilities are there. Either from the left side alone we could get the maximum subarray sum, and either in the right hand side alone we could get the maximum subarray sum which returns the largest sum. Otherwise, across the midpoint also we might get the maximum subarray, right. So, every time we are supposed to identify three values. So, if you take this problem, we clearly know that through the left sub problem the maximum sum value we could get is 1, and through the right sub problem the maximum sum value we could get is -6. What about the across the midpoint? Across the midpoint, if you check, -6, 1 minus 6, which is going to be -5, right. So, across the midpoint we are getting -5. Now, compare the max sum of the left sub problem, max sum of the right sub problem, and across the midpoint. Whichever is maximum must be returned to the previous level. So, if you compare -5, 1 and -6, 1 is only greater. So, 1 should be returned over here. The same way, if you check this side, the maximum sum is 8. If you come to the previous level again here there is one element which is 8. So, the same 8 would be returned over here. The same way here this side also, for this problem, through the left subarray we got maximum sum as 6, through the right subarray we got the maximum sum as -2. Now, we are going to check across the midpoint. Across the midpoint, if you check, 6 minus 2 is 4. So, now you compare, across the midpoint we are getting 4, from the left sub problem we are getting 6, and from the right sub problem we are getting -2. So, compare these three values, whichever is maximum should be returned to the previous level. Since 6 is greater, we are returning the 6 to this level. And then again this side there is only one element which is 5. So, same 5 should be written over here again. Now, come to this sub problem. Now, again this sub problem got divided into two. Through the left sub problem we got the value 1, through the right sub problem we got value 8. Now, across the midpoint we are supposed to check. Across the midpoint, how much we are getting? 1 minus 6 plus 8 is going to be, 1 minus 6 is -5, -5 plus 8 is 3. Across the midpoint, the max cross we are getting is 3. Through the left sub problem we are getting 1, through the right sub problem we have got 8. Out of these 3, the maximum is 8. So, we are supposed to pass this 8 to the previous level. Same way, look at the right sub problem. Here, if you take this problem, this got divided into 2. Through the left sub problem we got 6. Through right sub problem, the maximum cross so far, the maximum sum value so far we have received is 5. Now, across the midpoint we are supposed to check. Across the midpoint, if you check, 6 minus 2 plus 5 is going to be 9. So, across the midpoint is 9, left sum is 6, right sum is 5. Out of these 3, the maximum value is 9. So, we are supposed to return 9 over here to the previous level. Since this is going to be our last level, if you check the whole problem, the maximum one is the maximum from the left as well as right has been written. So, finally, if you add left sum and right sum, that is going to be our final sum, which is 9 plus 8 is 17. Now, if you check 17, 9 and 8, 17 is only greater. So, the maximum subarray sum from this array we could get is was 17. So, the value is, the final answer is going to be 17. This is how we are supposed to find the maximum subarray sum using divide and conquer method. So, here in this method we are getting only this, we are calculating only the sum value. We are not returning the array, like what are all the array, exactly which subarray and what are all the elements, it is not going to return. If you want, you can use again the pointer and like the value details also can be returned. But if you check here, I think this subarray 8, 6 minus 2, 5 has given the maximum sum value, which is 17. So, if you want to return the values also, the subarrays also, if you want to print, that also can be printed, but the maximum sum value we could get from the given example is 17. Let's discuss the pseudocode now. So we are supposed to identify here the left sum value, right sum value, and across the midpoint, which is called max cross. So 3 values we have to identify: left sum, right sum, and max cross. Every time in each step these 3 values should be identified. Out of these 3, whichever is maximum should be returned back to the previous level. Let's discuss the pseudocode. So here the first step is about, the first section portion is about max cross sum, which is across the midpoint how to identify. Let's see, let's take the same example only. I'll take the same example again for your understanding. So this is what we have taken, right? 1 minus 6, 8, 6 minus 2, 5. Let's trace the pseudocode now step by step. Here the midpoint is this one, right? This is our mid, this is our left, this is our mid plus 1, and this is going to be our right. Now let's check now. To find across the midpoint, these are the steps. Initially we are going to set left sum as minus infinity. Why? Because the array has the combination of both positive as well as the negative integers. So we have kept initial value, we are initializing this left sum variable as minus infinity, and also we are initializing the sum variable also as 0. Initially the sum value would be 0. Later on when we start doing the process, the sum value and the left sum value would get updated based on some conditions. So initially I am going to set up the left sum variable as minus infinity and the sum as 0. Now I am going to across the midpoint we are supposed to start, right? This is our midpoint. So from midpoint we have to traverse here till low, and then again from the midpoint we have to traverse towards the right pointer later to calculate the right sum. To calculate the left sum we are supposed to start from the mid, from mid till low we are supposed to traverse. So here I value, we are using a loop here. The I starts from exactly the mid value, it should traverse till the left pointer, and we have to keep on, like once each and every element is processed we are supposed to decrement the I value. Initially my I value is pointing 8, so my array of I is 8, right? The next step is sum equal to sum plus array of I. Initial sum, currently my sum value is 0 and my array of I value is 8. So 0 plus 8, my sum value would become 8 now. After calculating the sum value, the next step is I am comparing whether the sum is greater than left sum. Check whether the sum is greater than left sum. Yes, sum value is 8 and left sum is minus infinity. So here the sum value is greater than left sum. So I am supposed to update my left sum value as the sum value, which is 8. Then again go back to the for loop. The next step is after completing all these 3 steps, we are supposed to decrement our I pointer. So now my I pointer would be pointing minus 6. Check again, check sum equal to, calculate sum equal to sum plus array of I. Current sum value is 8, current array of I values minus 6. 8 minus 6 is going to be 2. So the sum value is going to be 2 now. Now check, the next step is we have to compare sum value with the left sum. Only if sum is greater, left sum should be updated as sum. But now if you check, sum value is not greater than left sum value. Sum value is 2, left sum is 8, which is not greater only. So you no need to change the left sum value, simply decrement the I value. Now I is pointing the value 1. Check, yeah, after decrementing it, I is pointing 1. Now you start calculating the sum value. Current sum value is 2 and the left array of I is going to be 1. So 2 plus 1, which is going to be 3. Sum value is 3. The next step is compare sum and left sum, whether sum is greater than left sum. No, sum is lesser than left sum. So you no need to change the left sum value. Again start decrementing the I value. But here the condition given here is until I greater than or equal to left only it should traverse. So after reaching the left it would come out of the loop because there are no more elements to process. So now finally, and the left sum value, the maximum sum we could get from the left subarray is only 8. If you check the example here, we would have returned only 8 only. Yes, the answer is correct. Similarly, we are supposed to process to calculate the right sum also. Let's check the right sum. So when it comes to calculating the right sum, as usual, check initialize the variable right sum variable as minus infinity. Why? Because we have a combination of both positive and negative values in an array, and set your sum value as 0. Now start again. To calculate the right sum, the pointer should start from mid plus 1 and it should traverse till the right. Yes, starting from mid plus 1 and it is traversing till the right, till the last index. Now my I is pointing mid plus 1. Calculate the sum value, sum equal to sum plus array of I. Initially sum is 0, array of I is 6. 0 plus 6, which is 6. My sum value is 6. The next step is compare whether sum is greater than right sum. Yes, sum is greater than right sum only, so update your right sum as sum. Again, after doing this process, we are supposed to increment the j pointer. So if I if I increment the j pointer, my j pointer would be pointing this. Now my current sum value, calculate the sum value. Current sum value is 6 and current array of I value is minus 2. 6 minus 2, which is 4. So your sum value is 4 now, and as a next step you are supposed to compare sum value and the right sum value. If sum is greater, update the right sum, otherwise you no need to update. Since sum is not greater than the right sum, you no need to update the right sum, simply increment the j pointer. Now j pointer is pointing 5. Now if you check, the current sum value is 4, so sum equal to sum plus array of I. Sum value is 4 and the current array of value is 5. So now the sum value would be 4 plus 5, which is 9. Update the sum value, which is 9. After updating the sum value, check for this condition whether sum is greater than right sum. Yes, sum is greater than right sum only, so update the right sum value as sum now, which is 9. And again go back to the for loop, you start incrementing the j pointer, but the condition given here is j till j lesser than or equal to right. We have reached the right pointer. After right, there are no more elements to process, so it would come out of the loop. So finally, if you check the right sum, under the right sum we are retaining the value 9, which means the left, under the left sub problem, the maximum sum value we could get is 9. Let's check the example, solve the example. Yes, under the right sub problem, the maximum sum value we could get is only 9. Yes, we got the same value even after tracing the pseudocode also. So here we got 8, the left sum value, and the right sum value as 9. So to find the max across the midpoint, max cross sum means across the midpoint. Across midpoint, we are getting the sum value as, the formula to calculate across the midpoint is left sum plus right sum. If you add left sum and right sum, 9 plus what? 9 plus 8, we would get 17. So across the midpoint is 17. When you compare 8, 9 and 17, 17 is only greater, and so this is going to be the max subarray sum. But how to, so for making the comparison and all, we have written the code over here, the second portion, finding max subarray sum. So here, if the element has only one element, when left is equal to right, which means there is only one element in an array, means it would return simply the array of left. Array of left and right are going to be same only, so it would return array of left. This is the base case. When there is only one element, directly you can return the same element only. Otherwise, if there are more than one element, we are supposed to find the midpoint. To find the midpoint, the formula is left plus right divided by 2. After identifying the midpoint, we are supposed to do 3 steps. One is finding out the left sum. Left sum would process right from left till mid, and finding out the right sum. Right sum would get processed right from mid plus 1 till right, and find out the cross sum. To find out the cross sum, you have to go across the midpoint. So left, mid, right, everything, like all the elements would get processed when you go across the midpoint, right? After identifying all these 3, we are supposed to make a comparison. You have to check, you have to compare the left sum with the other 2 variables. Left sum is greater than the right sum as well as it is greater than the cross sum, means find the maximum should be the the maximum subarray sum value is going to be the left sum value. Else, check the right sum value, compare the right sum value with other 2 variables with the left sum as well as the cross sum. If right sum is greater than the left sum as well as the right sum is greater than the cross sum, means the maximum subarray sum is going to be only the right sum only. Otherwise, it would return the maximum subarray sum is going to be the cross sum value only. So this is how the algorithm would get processed and the maximum subarray sum value would be returned. Now let's move on to the time complexity analysis. Since we have used divide and conquer method, we can't directly trace out the pseudocode and calculate the time complexity. No other go, we have to frame the recurrence relation and apply any of the method to solve the recurrence relation to and derive the time complexity. T of n equals to, if you check here, if there is a problem, one single problem, in the next step you are dividing into 2 equal halves. If the problem size is n, in the next step the problem size is going to be n by 2 plus n by 2, right, which means every time we are getting 2 sub problem and the sub problem size is going to be n by 2, and also again every time in each iteration we are solving both the sub problems only, right. Since we are concentrating on both the sub problems, we are getting 2 and we are concentrating on both, we are solving both the sub problem, we can write it as 2t n by 2. Other than dividing it, what are we doing? We are finding out the left sum value, right sum value, the across the midpoint, everything we are calculating it, right. So to calculate all that, this is the first section, right. This first section indicates, right, this section across after, like, other than dividing it, what else we are doing? We are finding out the left sum and right sum. After finding out the left sum and right sum, we are summing up left and right to identify the max cross sum, which is across the midpoint, right. So for this section, the time complexity is going to be big O of n. Big O of to calculate max cross sum, which means across the midpoint. So other than dividing it, we are finding out max cross sum as well. So the recurrence relation is going to be 2t n by 2 plus big O of n. This is the complexity. So here 2t n by 2 represents the time for the two recursive calls, left sum as well as the right sum, and big O of n represents the time to find the max cross sum. Time to find the max cross sum, which is across the midpoint. Now if you apply Master's theorem and solve this recurrence relation, you would get big O of n log n. So this is the final complexity to identify max subarray sum using divide and conquer method. So using divide and conquer method, we got the time complexity as big O of n log n. In the previous video we used brute force method, right. Using brute force method, we got the time complexity as big O of n square. So if you compare brute force and divide and conquer method is the efficient one. Why? Because it consumes lesser time complexity, which is big O of n log n. Is there any other better way to reduce the time complexity to find max subarray sum? Yes, it is there, which that method is called the cadence algorithm. That would be discussed in the next video with the time complexity of big O of n only. Let's discuss it in the next video. Thank you.